In this section, we're going to look at common logs and some of the properties. So first, let's just try to do a couple of the logarithms because we did kind of talk a little bit of the meaning, but let's just try to think about how we can evaluate a log. So if you think about logarithms, if you have log base 2 of 4. So remember, a log says, what power should I raise 2 to get a 4? Well, that's just going to be really easy because 2 squared gives me 4. So the answer is going to be 2. And if you think about it, when we convert it to exponential, 2 to the 2 gives me 4. Okay, so that's kind of how you really want to think about it. So what would this be? So what would log base 3 of 27 be? So what power should I raise 3 to get 27? And the answer in that case is 3. Because 3 times 3 times 3 is going to give me 27. Can you think of what this one might be? So if you said 4, that is correct. Because 3 to the 4th power gives me 81. So you do have to do a little bit of thinking. You can always use your calculator. Your calculator, if you have the base, all you got to do is just press the log button 3 times and it'll give you the base, especially if you have the TI-36. So right where it says if you have the TI-36X Pro, what you really want to look for is ln and log, and just press it 3 times. And then you'll be able to put in all of these different things. So some of the properties though, and common logs that you'll see is that you're going to see a couple of things. One of the things that you will see is just log 10x. Now, because this is log base 10, whenever something is base 10, we just change it and we say log x. So we don't write any base. So this one's just a base 10. So you don't have to write a 10 on the bottom one. If you write it right now, it's fine, but usually if there's no base there, that means that it's just going to be base 10. Okay, now another one is that you're going to see is log e of x, and we don't write log e, we just write ln of x, and this is what we call the natural log. Okay, so this is the natural log of e. So if you write log e, it's fine, but normally we would write ln of x. So what do you think ln of e is? Well, remember, we don't write ln, it just means e. So basically there's an imaginary e in there. So what should I raise e to get another e? Well, that's easy. That's just 1, because anything to the power of 1 is just that same thing. So that's what that is. Okay? So let me give you a couple properties to really know. I really want you to know these. So here are some of the properties. Log base a of a is equal to 1. So if the base is the same and so is the argument, the inside is what we call the argument. If they're the same, that's just equal to 1. Okay, and that's easy because a to the first power equals a. If you see something that looks like this, log a of a to the x, this equals to x. All right. And then if you have a to the power of log base a of x, this also is equal to x. So really keep these in mind. This is going to be really useful for when we solve some of the problems, but this is basically what you have for right now. Okay. So now let's get to the properties. So there are some properties of logarithms that I do really want you to memorize. And I'll write them right here. So you have some other properties. Properties of logs. And these properties work the same with natural log and also with the base 10 one. So this is what we're going to call the product rule. And basically what the product rule says is that if you have a log base a of m times n, so two things being multiplied together, this is going to be the log of a of m plus the log of a of n. So basically, if you have two things being multiplied together, all you got to do is separate them, each with a log, and then put an addition in the inside between them. if you have log base a of m divided by n, well, this fraction, if you have something divided by something, this is going to turn into subtraction. Log a of m minus log a of n. So that's what you're going to have. So this fraction will turn into subtraction. Okay? And then this is what, I forgot to write the word. So this is the product rule. This first one is the product rule. The second one is not the product rule. This is what we're going to call the quotient rule. I forgot to write the name of it. This is the quotient rule. This is the product rule. The last one is what we're going to call the power rule. Okay? And what the power rule says is that if you have the log of a of m to the power of p, this is going to be p log a of m. So basically, this p, this exponent, is going to go to the front. Okay? So right here. So that's really what these properties are. These you must know. These I will not give you. You have to know them. So memorize. So really memorize them. Okay, so now let's do a couple of problems. The best way to do these is just to do a whole bunch of problems. Okay, so we'll start off with some expanding and then we'll do some condensing. So using these properties, use properties to expand the logs. Okay, so here is my first problem. Log base 5 of 8y. I'll write it like this. Okay, so we want to expand the log. So the first thing that you want to think about is, okay, what property is being acted on this argument, on the thing in the inside of the parentheses? So the operation that's being acted is multiplication, so that we're going to use the product rule. Okay, so when two things are being multiplied together, we're going to separate them each with a log and then with an addition in the inside. So what is this going to be? This is going to be log 5 of 8 plus log 5 of y. Okay, now you are done when there's no exponent or anything together. Okay, and that's it. You can't reduce the log 5 of 8. That's going to give you a decimal if you put it in the calculator. But that's just it. You're just going to write that. Okay? Alright, so now let's do another problem. So let's say we had log x to the negative 3. Log base 10. So remember, this is base 10 because there's no base. So what are we going to do? Which property should I use here? Well, I should use the power rule because I have something to raise to the power. So I'm going to move the 3 over. So this is going to be negative 3 log of x. And that's it. Alright. Okay, now let's say we have something that looks like this. Let's say we had log base 2 of 2x to the 5th power, y to the 3rd power. Okay, so how many things are being multiplied? Because we know we have to use the product property, the product rule. So we have 3 different things being multiplied. So how many addition signs am I going to have? 3. So the first thing is going to be log base 2 of 2. That is the first thing. Plus log base 2 of x to the 5th. Plus log base 2 of y to the 3rd. Okay? Can I reduce this log base 2 of 2? Yes, I can. What power should I raise 2 to get a 2? That's just 1. Plus, what can I do here? I can move the 5 over. So that's going to be 5 log base 2 of x. And then I can't do anything anymore because now we have x by itself. Plus, this 3, I can also move it over. It's going to be 3 log base 2 of y. And that's it. I cannot do anything else. This will be my final answer. Okay. Alright, so let's do 2 more problems with expanding. So just to make sure that we got them right. Okay, so this was part, this should be a C. So let's do part D. So part D is log base 5 of 4ab cubed c to the 4th power divided by d squared. So let's say we did something like that. Okay, so the first thing that we want to do, before we do any product or power property, let's first get rid of the fraction. The fraction might be freaking you out. So let's get rid of it. Now, because there's a division here, this fraction is going to turn into subtraction. So we're going to use the quotient rule. So this is just going to be equal to log base 5 of the top part, 4ab cubed c to the 4th power, minus the bottom part, log 5d squared. Okay? Okay, so now let's go ahead and solve the top part. This is going to be, so now we have how many terms up here? 1, 2, 3, 4. So we have 4 terms, so we're going to have 4 pluses. It's going to be log 5 of 4 plus log 5 of a plus log 5 of b cubed plus log 5 of c to the 4th minus, well, here we can just bring this 2 over, 2 log 5 of d. Okay, now that we're almost done, all we got to do is just move everything. So this way we cannot simplify it anymore, so that's just going to stay as log 5 of 4. This one I can't do anything else, log 5 of a. The 3 can go to the front, 3 log 5 of b. The 4 can go to the front, 4 log 5 of c. And then this minus 2 log 5 of d. Okay, and that is going to be my final answer. Okay, good, good. Now let's do one more, and then we'll do condensing in the other video. This was part D, this is going to be part E. So this one is as difficult as it's going to get. This is going to be ln, which is a natural log, of the 5th root of 3x squared divided by 4y cubed z. Now you might be thinking, can I skip a couple steps? And the answer is yes, you can skip steps if you'd like to. Okay, so the first thing to do is let's get rid of that 5th root. So how can I get rid of it? Well, is there a way that I can convert this to an exponent? And luckily we can. ln of, I can write it the following way, 3x to the squared divided by 4y cubed z to the power of 1/5. Because remember, that's how you can write it as a rational exponent. And now this 1/5, I can bring it to the front. You can distribute it inside, but I think it'll be easier if you just bring it to the front. So this is going to be 1/5 ln of 3x squared divided by 4y cubed z. Okay, now this fraction is going to turn into subtraction. So it's going to be 1/5 ln of 3x squared, so that's the numerator, minus the denominator, ln of 4y cubed z. Okay, here we have two different things. Don't worry about the 1/5. The 1/5 is just going to stay outside. So 1/5, we have two things, so this is going to be ln of 3 minus, plus ln of x squared. Now be very careful with this minus, because before we expand everything, we have three things here. Well, we have to be very careful because this minus is going to be distributed for every single thing. So this is going to be ln of 4 plus ln of y cubed plus ln of z, all in parentheses, because this negative is going to be distributed in a little bit. Okay, so we are going to have to distribute this. So don't forget it, because this minus, sometimes we forget it and we just give it to this one, where it has to go to all of them. All right, so we're almost done. It's going to be 1/5 ln of 3. Let's move this over. 2 ln of x minus ln of 4 minus, let's move this over, 3 ln of y minus ln of z. Okay, now you can choose to distribute the 1/5 if you like to, or you can just leave it on the outside. Okay, so that's usually, this is as hard as it's gonna get. Make sure that you start it, it's a really good problem. All right, so in the next video, I will show you how to condense.